Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 17th. Looking at significant wave heights for the North Pacific Ocean, we see a gale producing 28-foot seas approaching the dateline, but this system, though rather broad, is expected to fade some as it travels east, but still make pretty good headway into the Gulf of Alaska. Another little system is trying to get organized here off of North Japan, and otherwise, a weak low-pressure system is trying to generate some seas off California, but not a whole lot is expected from that. Winter is definitely winding down. Let's take a look at the details. First up, let's take a look at jet stream level winds. These winds help support the formation of gales, and when those gales do form, help direct their path. We're looking for a trough, and a trough is this, a dip in the jet stream with some wind underneath it, here at 140 knots. That helps support a counterclockwise flow in the atmosphere aloft and down at the surface, and that is the hallmark of low pressure. And of low pressure, of course, generates winds. Winds generate seas. Seas generate swell, and that swell generates surf when it radiates away from the fetch area and hits your beach. But right now, in general, the jet stream is kind of a mess. We have a pretty good flow trying to push off Japan here, aided by El Nino, but then it splits here just barely off the coast, with the southern branch tracking down around about 18 north or so, and eventually pushing into mainland Mexico, where the northern branch kind of meanders around. Yeah, there's a little bit of a trough here, a little bit of a trough here, a steep trough here, and then a big ridge here. That is a ridge pushing the jet north. So there's little bits of support for low pressure in each of these three areas, and just looking at the significant wave height chart, we saw that in fact there is some sea generation trying to go on in all three of those areas. Let's put this into motion. Take a look. First off, the trough in the Gulf pinches off. The trough here, we're into Monday morning. The trough that was over the dateline pretty much washes out, but the split becomes less pronounced off Japan. We'll roll this out some more, and we see a pretty good pocket of wind energy here. What's that, about 170 knots? No real troughs forming, a little bit of a kind of a cutoff thing here, but I mean, there's just no wind energy associated with that, so that doesn't do much for generating storms or fetch or any of that sort of thing. We roll this out better, and now notice here we start getting a trough come Wednesday in the Gulf of Alaska, again with 170 knot winds falling into it, but that kind of wimps out, backs off, and sort of tries to make a trough here off California on Thursday, but not really. But the interesting thing is the jet does push directly into Central California by Friday. That probably won't do much for surf production, but could do something to produce some more precipitation, maybe some snow aloft in the Sierra, and every drop counts at this late stage in the game. We get into about a week out Saturday. Notice the jet goes zonal. That is flat east to west on about the 38 north latitude line. A little bit of a split still here, but not a whole lot. We'll roll this out. No troughs, notice. A little bit of a weak broad trough trying to get going here on Sunday off Japan. We'll roll that out a week out. Yeah, so not a lot of wind energy, but not bad either given the time of year. We're into almost the end of April here. At this point, normally in any regular year, you'd be, get whatever you can get. If it was a La Nina year, the season would be over. But as of right now, there's actually reasonable surf pushing into Central California. Waves in the 1 to 2 foot overhead range at top spots. So not all horrible, and there's more swell on the way. Let's dig in a little deeper. So here we go, surface level pressure, surface level winds. We see high pressure here, 1028 millibars just west of the dateline. But of more interest, a little low pressure, weak. One closed isobar at 108 millibars. Nothing too strong here off of California. We expected that because remember there's a steep trough here. A far broader low, what is that, about 980 millibars over the dateline and the Aleutians, generating a fetch of 35 knot winds. Actually, there were stronger winds here earlier day or so ago, and that's what generated most of the seas that we saw in the charts, a couple of charts ago, 28-foot seas in this area, and then another little low trying to get going off of Japan. Let's roll this out. Notice the Japan low pretty much gets assimilated into this broader gale pattern. While this has come Monday, the low off California actually builds a little bit of 35-knot winds, but notice it's all aimed pretty much south between Hawaii and California, and it's a fish storm, basically. Roll this out some more. The gale here in the over the date line, another little pulse of energy builds into it. It actually moves into the Gulf come Wednesday with 30 to 35 knot winds. This is an upgrade from maybe about 72 hours ago. It was not expected to be this strong. If you have 35 knot winds, you could expect 20, maybe 22 foot seas out of that, and that would be good for 13-second period swell pushing into the U.S. West Coast, maybe sideband energy down into Hawaii. This is as of Wednesday night. And the system kind of continues to percolate up here into Friday. Look at that little patch of 45 knot winds. I mean, kind of not a big system, but still all that energy aimed right at the U.S. West Coast. But it also looks like there's some wind along the coast too. And here comes a string of yet more weak systems behind that. Roll this out. Notice here's high pressure gradient with low pressure inland. North winds start building along the coast. Roll this out some more, and more weak, small fetch areas out here, but nothing really solid. It sort of suggests, much like what the jet stream was suggesting, that the winter is trying to wind down, and just you get what you can at this point in time. You're not trying to find big surf, just rideable surf, because in a month you'll be groveling for wind swell. So that's kind of what it looks like at the surface. Let's go take a look and see how these winds affect the ocean surface and what they do in terms of sea production. So here we go, significant wave heights for the North Pacific Ocean. We are ignoring this one because we're going back Tuesday, almost, 5 days ago. It's this system right out here that produced swell that is currently hitting Central California. It also made good solid swell into Hawaii, maybe 10-foot Hawaiian on last Friday. And there you go. We had 38, 39-foot seas associated with this one. Nice little pulse of swell, and then that thing faded out on Thursday. That swell has radiated away past Hawaii, hitting California right now, and like we said before, maybe 1 or 2 foot overhead surf at top spots. And it is, so we'll just roll this out. Here is the next system that developed on Saturday, 31-foot seas, again, even further west of the date line than the one before it. And we'll roll this out, and it makes it to about there. And this is what we're seeing right now, 28, 26-foot seas approaching the date line. Again, good for another pulse of swell for Hawaii for sure, probably in the 16, 17-second period range, and also inconsistent swell for the U.S. West Coast. And then looking at the forecast now, we see the system continue tracking over the date line come Monday morning. Was that 22, 23-foot seas, and our little low off the California coast here, 18 or 19-foot seas, but sort of falling south. Really nothing is expected from that. It is this system, the remnants of the system, we're watching as it moves into the Gulf. There we go, 22-foot seas, maybe 23-foot seas, and 1 Grib square there. Again, that should be good for a nice little pulse of swell. This is as of, what is that, Wednesday, Thursday time frame. So swell maybe by Friday. The issue is going to be whether there is weather associated with that, which sure looks like it probably will be. And then it sort of the secondary system rebuilds 26-foot seas. So certainly swell for the weekend for California and maybe into Monday, but likely weather with that as well. Oops. And then those other little systems we saw trailing behind. This is a week out, not believable. Maybe something to watch, because actually the model has sort of downplayed this stuff a week out, and then sometimes they kind of pop up a little bit stronger than expected. So for right now, it looks like there's going to be surf come the late weekend, but weather too, and wind. Probably nothing awesome, but again, get what you can get where you can get it. And then we'll take a quick look here at the southern hemi. A little bit of a gale here under New Zealand, but it's actually falling almost south east. That's not good for radiating, pushing swell or propagating swell up into our forecast area. Another couple of small spurious systems, but notice the track here. Watch this. Goes from here and it's falling southeast again. That same problem, and tiny on top of that. And then we look out, continue to look. Something we're almost a week out now. Something here due south of Southern California. Another system under New Zealand. You know, kind of pushing to the northeast here and here, but a week out, find that very, very hard to believe. Still, at some point, the southern hemi should start coming online, and the late April, early May time frame would be about right. So let's go talk long term. What's happening out, the next 6 months or more. The fading remnants of our big El Nino from 2015-2016. And what we're looking for is the presence of west winds in the Kelvin wave generation area. That area from about 35 east out to about 170 west, and about 5 degrees north or south of the equator. Actual winds, we see trades in play, anomaly-wise, and all this from the TAO buoy array, hard buoys on the ocean surface. You can't get any better at reporting than that. Pretty much showing no real west, a couple little bit of weak anomalies down about 5 south, but nothing strong. Mainly, there's no wind in this area. We're looking for west winds for one, creation of Kelvin waves, though we don't expect a Kelvin wave to develop because there is no warm water left in this area to push to the east. This El Nino has basically tapped this area dry, and there's nothing left. We're also looking for west winds because even in the absence of warm water here, westerly winds would signify the active phase of the MJO, and the active phase of the MJO, when it passes through this area, tends to enhance the jet stream in the North Pacific, and as we saw from previous charts, an enhanced jet stream helps support the formation of storms in the North Pacific in the winter and even spring months. But we're not seeing that either. And here we go, 850 millibar wind vectors. These are anomalies. So the Kelvin wave generation area is, just draw a box right here. And here's that little patch of westerly winds we see. That was as of April 11th. We'll just scroll down day by day. You can see some degree of westerly winds still there, but nothing really on the equator. It's more well south, down around 10 south or so. So nothing interesting there. And here's the forecast. Reds and oranges are anomaly for westerly anomalies. Blues are easterly anomalies. Here's the Kelvin wave generation. This is the area. This is the whole world on one chart. Kelvin wave generation area is roughly from about here to about here. And sure enough, we see very weak westerly anomalies. Maybe a little bit of patch out on the 22nd of April. But really, this is the expression of El Nino here, not the MJO, and just, nothing particularly impressive. Here was a little bit stronger westerly wind burst even in the end of March, but again, there was no warm water in place even then to create a Kelvin wave. It did sort of help push up the storm track for a little bit, but now we're kind of in the dead zone here. El Nino trying to continue, but it's getting late in the season. So next up, we look for the presence of the active phase of the MJO, because the active phase of the MJO helps support the jet stream, and that, just that alone could help kick up a storm, or at least help enhance storm production. Blues, so this is outgoing long wave radiation, sunlight, reflectivity off the ocean surface. More clouds means less reflectivity. These blues, see negative numbers here, suggest the active phase of the MJO. And what we have is a very weak expression of the active phase of the MJO forecast for the next 2 weeks, limited to the maritime continent. We really want it out in here more. Really no change per the statistic model forecast for the next 2 weeks. And the dynamic models suggest a weak eastward movement 2 weeks out. That would be nice. Not particularly strong, but every little bit helps, because the interaction of the active phase of the MJO with a weak El Nino pattern would help perhaps fuel a little bit of storm development. Now notice, the statistic model says nothing. The dynamic model says this, so there is a definite disconnect between these two models. Here's yet another way to look at this. Assume you're looking down on the North Pole from out in space, And as you look down and go counterclockwise, you go from the maritime continent over the dateline to the West Pacific, over the Americas into the Atlantic, over Africa, and back to the Indian Ocean. The big dot here shows where the active phase of the MJO is, and if you're inside this circle, that means the MJO is exceedingly weak. You want to be out in here somewhere. So the ECMF model says the active phase of the MJO is like over the maritime continent, but exceedingly weak, and forecast for the next 2 weeks, the green line is the forecast to basically do nothing. The dynamic model here, the GFS ensemble model, suggests pretty much the same thing, or if anything, maybe perhaps trying to make some headway into the West Pacific. So, general consensus, weak MJO, 2 weeks out, the forecast, no consensus. So the same situation as what we saw in the previous charts. And then here we go. This is the CFS model. This is current time. Now this runs a little different. Past history is back here. Big, strong, active phase of the MJO here. Westerly wind anomalies back in January. Another pulse back in February, early March. And here's where we are now, kind of in a dead zone. Weak westerly anomalies. And the forecast, though, kind of interesting, suggests a enhancement or slow, gradual building of westerly anomalies. Maybe by the end of the month, what's this, the 25th or so, things start building and continue in some fashion through the end of May. That would be nice. Let's overlay the MJO. Now, this is interesting. This model says we're in the inactive phase of the MJO. The dotted lines are the inactive phase, but yet westerly anomalies are to actually build. So this would suggest an extremely weak inactive phase, and this is all attributed to El Nino, and then a equally weak active phase in the late April, early May time frame, and then things sort of peter out. We suspect all this active inactive is almost immaterial, and if these west anomalies do develop, it's all going to be attributable to El Nino. We'll take it if it comes. That would be nice. We're not holding our breath, though. So again, all the models kind of confused. That's not unexpected given how weak the MJO really is. I think it would be safe to expect that basically no MJO influence for the next month, but that might give with no inactive phase stepping on El Nino might actually get a chance to manifest itself a little bit more in the atmosphere and create some west anomalies. That, of course, would help fuel the jet stream and maybe get a little push for a late season storm cycle, but probably not much. So we've talked about westerly winds, and we've talked about Kelvin waves or lack thereof. Notice here is warm water, 29 degrees centigrade. It was working its way over into this region here and is steadily retreating to the west, which suggests the subsurface ocean temperature profile is starting to return to a more normal situation. El Nino takes warm water, displaces it over here where it's normally quite cool due to trade winds and upwelling in this region. Those trades blowing across the Pacific from east to west take warm water, typically pile it up here in the far West Pacific, and we see that starting to happen now. Anomalies, differences in normal for this time of year, and what we see is the very last of the warm subsurface pool created by El Nino, 1 degree anomalies, maybe a little pocket here of 2, but that's even doubtful. And this is steadily shrinking. The big notable thing here, notice this is like a cold water Kelvin wave steadily working its way subsurface to the east. Eventually it's going to push through somewhere around here and wipe out the last of the warm surface pool around Ecuador and that region. In fact, we already are seeing some signs of that. We'll get into that in a minute. So the last little bit of the subsurface pool in evidence here. The zoomed in view, even showing it better. Here's the cool subsurface pool working its way into Ecuador. The very last of the warm pool basically being undercut. This is getting pushed off to the west by trade winds, and you can just see this guy's just going to come right in here and boom, blow up to the surface, and all of a sudden we're going to see this really cool pocket of cool pocket of water develop around the Galapagos and start building as all this starts pushing in to the east, and then that would be the start of La Nina. You can see it in this chart as well. This is the upper 300 meters ocean temperatures, West Pacific here, East Pacific here. Here were Kelvin waves, and you can actually see it back last year in the spring time frame, again in June. Far bigger one last year in August, September, even bigger one in November. One last baby one, this was what, number 5, I think, in the January, February time frame, and then you can just see the subsurface warm pool crashing, and here comes your cool water. Notice it building in coverage here, working its way to the east, again indicating El Nino is fading. And yet one more piece of data showing the same thing, actually showing it stronger still yet. This is sea height anomalies, differences in normal. High 5 centimeters. So basically you strip out all the waves, the tides, the chop, and there's a good database that says what the height of the ocean surface should be around the planet. This suggests warm water at depth, but notice here right in the main El Nino region, here is the Galapagos, Ecuador, of course, Central America here. You see negative anomalies the whole way to the coast, meaning no warm water at depth. Warm water at depth basically expands and creates a little bulge on the surface. Cold water contracts and creates a trough on the surface, and that's what we're seeing with more cold water on the way. So that sort of marks the end of El Nino. And here we go, actual surface temperatures. As we said, we knew there was cool temperatures subsurface, but here we go. Here's the first manifestation of it. Here's the Galapagos, Ecuador right there. What is that? About minus, somewhere around -2 degrees for normal. The exact opposite of El Nino, which is all about warmer than normal water in this region. So in the Nino 1.2 region right here, temperatures appear to be crashing fast. La Nina is developing. Also notice it's building along the Peruvian coast up into Colombia, pretty much saying this is over. Here's the last of our warm pool out here from about 100 west out to 160. Still some pretty, a couple of pockets here of, I don't know, 1.75, almost 2 degree anomalies here. But that is fading fast. We'll look at the indexes in a minute here. Here's actual water temperatures. These are actually anomalies, differences in normal. But you can see the cooler anomalies here starting to build near the Galapagos. But still a pretty the typical El Nino pattern to be sort of a triangle that goes out to here and down to here. And you can still see, what is that, about 1 to 2 degree anomalies, maybe some pure 2 degree anomalies in pockets here, which in a normal year you'd go, that's El Nino, and it certainly is. El Nino is still in play, and it's certainly affecting the atmosphere. Subsurface-wise, things don't look good. At the surface for this time of year, things are doing pretty well as expected, and that's still imparting energy to the atmosphere and the jet stream, and that's not going to change anytime too soon. The momentum is set at the jet stream level, and it will take probably a year for it to completely dissipate. Certainly through the fall, early to mid to late fall of this year, you'll still see manifestations of El Nino in the atmosphere for sure. But sometime as you get into the later part of midwinter, that should fall apart. But not too bad given where we are right now. Now, here is the differences in temperature over the past 7 days. And the blues are decreases in temperatures, negatives. And you can clearly see the pattern is well in play here, that temperatures are crashing over the entire Nino region right like that. Yes, still some lingering remnants here and there, but definitely a downward spiral. Looking at the index for the Nino 1.2 region, this is right around the Galapagos, Ecuador, Peru. Clearly we can see temperatures which were positive. Even a week ago were, a 1 degree positive. In the last 7 days have crashed. They're now minus 7.722 degrees. So all the data correlates well there. But out in the Nino 3.4 region, the main area for monitoring El Nino, and that's pretty much the area south of California out to the dateline or so, we can see anomalies were up to almost 3 degrees back in January and have slowly been working their way down, but still plus 1.25 degrees, let's say. That's over a pretty good large area, and that's what we saw in the sea surface temperature anomaly chart. So still, manifestation of El Nino clearly present in the main Nino 3.4 area. So how did this year's El Nino stack up to other significant El Ninos over the past 50 or since 1950? So it'd be about 66 years. Well, this is in, again, Nino 3.4 region only, okay? Peak anomalies in the 97-98 El Nino were 2.32 degrees, and that was the strongest El Nino ever. This year's anomalies were 2.36, besting that if one looks strictly at the data. And then the 82-83 El Nino was up at 2.21. So according to this, just in the Nino 3.4 region, and these are centered temperatures, they're kind of, the oceans have been warming steadily for 30 years or more now. This tries to account for that and puts everything on equal footing. Even with that, it says this year's El Nino was the strongest ever. But what it doesn't show you is what the temps were in the Nino 1.2 region. In 97, 98, and in 82, 83, they were cooking around the Galapagos, Ecuador, that area, where it was very mediocre in this El Nino. So what that suggests is this El Nino, though it was warm out in the dateline on the ocean surface, over towards and south of the Americas, it was not that warm. And that is our personal explanation of why the precipitation was not as strong in California as had been hyped by many sources earlier in the year. Mainly, I don't want to say this was a Modoki El Nino, because it certainly was not, but it sort of acted like one in that wherever the peak temperatures are, that's where the peak precipitation is. And in terms of aerial coverage, it was out in the Nino 3.4 region, so let's say south of Hawaii out to the dateline, and that's probably where most of the precipitation was, which basically means it was a fish storm, and it didn't do a whole lot for us. Snowpack up in the Sierra right now is about 87 to 89% of normal, maybe a little bit more, maybe low 90s, which isn't bad. We're doing well. It helps replenish the reservoirs. We got a decent snowpack, but mainly it's a higher elevation snowpack too, because El Nino tends to be warm. Most of the snow this year was 6,000 feet and above. There was coverage down low, 5,500 feet, something like that. But there was not a whole lot of cold storms where we got snow, good solid snow down at, 2,800 feet or 3,000 feet, something like that. So just more data to use to put in your memory bank to compare this El Nino to either previous El Ninos or El Ninos yet to come. All right, so how well is this El Nino coupled? That is the warm water coupled with the atmosphere. One way to manage that or visualize it is through the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Typically, if you have a strong El Nino, high pressure sets up over Darwin, low pressure sets up over Tahiti. That drives this daily index negative, and the active phase of the MJO will also do that. And this is very interesting here because notice we've had consistently negative numbers here all month and getting much stronger lately. Also notice that the 30-day running average is starting to go negative. This suggests the active phase of the MJO as well. The 90-day running average, which suggests the presence of El Nino, is slowly weakening as one would expect, but still quite negative, minus 13, suggesting El Nino is very much in play in the atmosphere. And so we have this suggests an active phase of the MJO is setting up along with El Nino, which might actually help enhance the storm track in the next coming couple of weeks. The ESPI index basically does the same thing. Here's Darwin. Here's the area north of Darwin. It does it with precipitation. Here's the Nino 3.4 and a little bit larger area, probably Nino 2 to Nino 5 if there were such a thing. But it measures total coverage of precipitation in these two. Positive numbers in the index suggest a good coupling with the atmosphere for El Nino. It actually was down to 0.73 or 8, I think it was. Now it's up in the past couple of days up to 0.93. So still, and here you can actually see here's your rainfall anomalies here. Still a good amount of rainfall in this area. Pretty dry off in here. So El Nino, well coupled. Now let's talk about trends not 6 months or a year out, but maybe multiple years, maybe the next 10 years or more. The Pacific Decadal Oscillation. This runs in cycles like 15 years. So just for laughs, here was 97. You wanted positive numbers. So the PDO sets up, the theory is anywhere from 15 to 30 year cycles, either that support El Nino or support La Nina. So if you look here, negative numbers suggest the La Nina phase of the cycle, and here's the 97, 98 El Nino. Very strong, very solid looking. As soon as we got into 98 in the end of that El Nino, numbers went negative. The PDO went negative, and if you just scan this closely, it basically has stayed negative until right about here, the beginning of 2014, and that's where this big El Nino cycle started. The interesting part here is you go down, look through this. Here is the March value that was just released, plus 2.4, suggesting, again, this is only 2 1/4 years worth of data here, 2 1/4, but suggesting that maybe, just maybe, we're turning the corner here and going from this down phase of the PDO into a positive phase of the PDO. Now here's another, we'll go back even further, 76, somewhere around in here, we were, you can look at here, look at all these negative numbers. It went and went and went, and then you get somewhere into about 76. This is all like an atmospheric era disposed to La Nina. Somewhere around in here, 77, 78, all of a sudden, the numbers start going positive. And they ran that way the whole way through 97 into 98. So what is that? 20 years or so. And it might have actually been longer. You could actually make an argument, say it started in the 75 or so. So there was let's say a 25 or so year, 20-year run of the an El Nino cycle, then what was that? Right there, 98 to there, a 15-year cycle of La Nina, and now maybe, with luck, maybe we're getting ready to go into another 15-plus year stretch of El Nino. Way too early to know. You probably need about 4 or 5 years of data here, but we're on a pretty good run. It'll be real interesting to see what this coming La Nina does, and let's say we get another year or two into this index and see how negative it goes, if it even goes negative, or if it just sits around zero and starts going positive again. That would be a real good sign that maybe we're in for much better time in the next decade ahead. So for now, another swell working its way towards Hawaii and the U.S. West Coast. Probably a bit of weather associated with it. After that, the models suggest maybe not a whole lot going on, but the longer-term models suggest maybe the active phase of the MJO is going to sort of give El Nino a little push, and we might get one last little cycle of activity out of the North Pacific. Southern Hemi not doing a whole lot yet, trying to get its act together, but still a bit early in the cycle. And then, of course, long-term, La Nina expected, but, well, will it be a strong one, or will it be weak, and will we work our way into the El Nino enhancing phase of the PDO over the next 5 years? Who knows? Something to watch. Anyway, that's it for this week. We'll do it again next week. Same time, same channel. See you here.